Today we're going to review factoring. What exactly is factoring? Factoring is the act of taking apart a number or expression and writing it as a product of all its smaller factors. Let's look at a couple examples. We've all seen the number 20 before. So what you want to look at is what are the smaller things 20 is made of? Well, you know some numbers that go into 20, like 5 and 4 are two numbers that multiply to go into 20. Are there any numbers that still break apart into 5 or 4? 5, no, 5 is what we call a prime number, but 4 does have some smaller factors. That's the same as 2 times 2. So the smallest things that we can break this up into is 5, 2, and 2, because 2 is also a prime number, nothing else goes into it. So another way of writing 20 would be as 2 times 2 times 5. Those are its smaller factors that multiply to get 20. So that's factoring, breaking things up into its smaller things. Let's take a look at one with variables. Let's say you have this, 15 a squared b to the third. Well, 15 we know we can break up as 3 times 5. A squared means you are multiplying a times another a. B cubed means the same thing, except we have 3 of them. So another way of writing 15a squared b to the cube would be 3 times 5 times a times a times b times b times b. Those are the smaller factors involved. Now to get us all kind of in this factoring frame of mind, we're going to try some what's called factor puzzles, trying to break apart and find the smaller things involved. So here you're looking for what's the common factor in each row and column. So looking at number 1, and let's just take this first row right, or first column right here. What is the common factor, the biggest common factor that 12 and 8 have between them? Well, 2 is a number that goes into both of those numbers, but even bigger is the number 4. 4 goes into both 8 and 12. Okay, now what goes into 12, or 4 times what multiplies to be 12? 3 does. So here, the combination of 3 and 4 gives us this 12 right here. So that's kind of what we want to do all around here now until we figure out all the numbers on the outside and fill in the missing blank on the inside. So 4 times what is going to be 8? 2 times 4 equals 8. Now, with these factor puzzles, if we have a 3 and 2 on this side, we also know 3 and 2 go on the opposite side too. So the numbers always are going to be the same on both sides. What we need to figure out now is what are these last 2 blanks going to be, and then it'll help us find that number that goes in the missing box and to complete the factor puzzle. The key to doing this now is to see this number right here, 15. 15, 3 is one of its factors. What is the other factor that 3 multiplies with to get 15? It would be 5. So we put a 5 here and 5 here. Finally, now we can figure out what goes in that missing box. 2 and 5 are the 2 terms that have to multiply to get this one in the box. 2 times 5 would be 10. So the missing thing in the factor puzzle would be 10. Let's try another one here. In the next one, we got 8, 14, 21 in the box. We want to figure out what's the other part of that factor puzzle. Again, look for the greatest common factor for each. So the greatest common factor between 8 and 14, they're both even, so we know 2 goes in there. Look for bigger even numbers. Would 4 go into both? Well, 4 goes into 8, but not 14, and so nothing bigger. So this would be 2 and 2. Let's do the same thing for this bottom row, 14 and 21. 7 go into both of those. Okay, so now let's figure out what else multiplies here. If we're looking at 8, what else multiplies with 2 to get 8? 4 does. So we can write 4 across as well. Now let's look at 21. 7 times what equals 21? 3 does. So if we write 3 there, we can write 3 up top. Now, if you look at these two, 3 times 4 is 12. 12 is the missing number in this factor puzzle. All right, for tomorrow, once you guys try the rest of these factor puzzles, try number 3 and also the ones down on the bottom here and see what you get. All right, so factoring. The types of factoring that we're going to be looking at today is a few different ones. And factoring is simply the opposite of doing foiling. If you remember, FOIL is the acronym we use in Algebra 1 and geometry to multiply two binomials. It also could be the opposite of distributing as well. So that some types of factoring is the opposite of distributing. When factoring answers will look similar to the original problems that we've seen before. So greatest common factor, that's where you are doing the opposite of distributing. You're looking for what is the greatest common factor, just like we did in those factoring puzzles and pulling it out. General trinomials, we're going to look at how do you factor general trinomials. This is the one that's the opposite of FOIL. General trinomials where you have a number in front of the x squared. That's where we're going to be using a process called grouping that we'll look at tomorrow. All right, let's try some examples out. Number 7, 8, these problems, they want us to use greatest common factoring. That's what GCF stands for, greatest common factor factoring. So we're trying to think of what is the biggest thing that these have in common. Let's look at the numbers 12 and 36. What's the biggest number that goes into both 12 and 36? Well, if you start low and you know that they're both even, 2 definitely goes in there. So see if there's any bigger multiples of 2 that go in there. 4. Would 4 go into both of these? Yeah. Now you don't want to stop there though. You want to keep checking. Is there any bigger ones? How about 8? 8 doesn't go into 12. It does go into 36, but we need it to go on both. If you keep going, 10 doesn't, but 12 itself actually does go in both of these. So the greatest common factor that we can pull out is 12. What you want to do then inside the parentheses is write what would be left over, what remaining factors would be left over if you were to distribute. So 12 times what is going to be 12x and x. 12 times what would equal 36? 12 times 3 would equal it. That is now factored out into 2 terms. All right, let's try another one. On the next one, what's a number that goes into 8 and 16? Well, 8 itself does go into 16. So the greatest common factor for numbers is 8. Now this one's a little different than the first problem. In the first problem, our second term, 36, did not have an x. Okay, it was just a constant term. In this one, however, if you look, both terms have at least one x in there. So our greatest common factor is also going to have an x. Can we pull out an x squared from both of these? No. Although our first term has 2 x's, our second term only has 1 x. So the biggest number of x's that we could divide these by would be just the single x. So now we put our parentheses and we figure out what's left over. So if we take 8x squared and divide by 8x, which is our greatest common factor, what would be left over? X squared over x, there would be just a single x left. So x goes in the first one. 8x times what is 16x? 8x times 2. And there's our answer. For tomorrow, I want you to see if you can try out 9 and 10. See what you get on those two. See if you can pull out the greatest common factor there. All right, the other one we're going to look at today is general trinomials. These are ones that look in this quadratic form of x squared plus bx plus c. Notice there is no number in front of the x squared on these. Okay, later we're going to look at ones where there are numbers there. It makes it a little bit harder, but for today we won't see any numbers there. What we want to do to solve these out is the opposite of that FOIL method. Okay, so if you have FOIL, if you have two things that you're multiplying, we want to do opposite of that here. And when you're doing opposite, that means whatever the two numbers are should multiply to equal this number. The two numbers should also add to equal that number. Some people, when they're doing these, like to make a little X type picture to help them out. So you can put the the two numbers 8 and 6 in here, and then you want to figure out what two numbers are going to multiply to 8, so multiply to this top number and add to the bottom number. Well, if you think about it, the two numbers that make this work would be 4 and 2. 4 times 2 equals the top number. 4 times 2, or 4 plus 2 equals the bottom number. So that's how we're going to write this out as two-factored terms. We would have x and x in the first part of our parentheses to multiply to equal that x squared there. And then the two terms that come after this would be plus 4 and plus 2. And that those two numbers would multiply to equal 8 and add to equal the 6. And that's our factored answer. Now, if you want to check to see if your answer is right, you could go back through and do FOIL on that and see if it works. Remember, FOIL stands for first, outside, inside, last. So if you multiply these back, x times x, the first terms equals x squared. The outside terms, x times 2 is 2x. The inside for I is 4x. And the last terms, 2 times 4 is 8. If you combine those middle terms together, you get the same thing we started with as the original problem. So yes, our answer did check out. Okay, let's try another one here. Number 12. They want us to do this one. So we want to think, what numbers are going to multiply to equal 12 and add to equal 13? Well, 12 we could have 4 times 3, but that's not going to add up to 13. We could have 6 times 2. That's going to add up to be 8, not 13. What we also could have 12 times 1. 12 times 1 equals 12, and 12 plus 1 equals 13. So this one would factor to x and x to get our x squared again, and then the numbers in the parentheses would be plus 12 and plus 1. There's the factored form. For tomorrow, why don't you try number 13 out and see what you get on that one. All right, the next ones we're going to look at are called difference of two squares. They're kind of a spin-off of the last one we just looked at, but they're a little bit different in that something's missing. In these ones, they're always going to be in the form where you're going to have that x squared part still, but you're going to have a numerical term or a constant term that's also squared. Whenever you have these, they are going to factor where you have x and x, and the number being squared will be the same term here. One of yours will have a minus, one of yours will have a plus. Let's look at some examples. Number 14 is x squared minus 4. This is really like the last problems we were just looking at. That middle term with the x is missing. So it's kind of like plus 0x minus 4. There's no middle x term. So if we're doing this one, we want to think what's going to multiply to negative 4 and add to 0. And the two numbers that multiply to negative 4 and add to 0 would be positive 2 and negative 2. Notice that both the number parts are the same. So this one factors to x minus 2 times x plus 2. Okay. Again, anytime you're doing one of these ones, these two numbers will be the same, the signs will be different. Another way to think about this one is what is the number being squared that equals 4? 2 is the number being squared that equals 4. That's why we end up with 2 here and here. Let's look at another one, number 15. X squared minus 64. This is another one where we're going to factor. It's going to be x and x. One's going to be plus, one's going to be minus. We got to think of what's the number being squared. What number squared equals 64? Well, if you go on your calculator and do the opposite of squared, take the square root. Square root of 64 is 8. 8 is the number being squared. So this is going to be x plus 8 times x minus 8. And that's the answer. Why don't you guys try 16 out for tomorrow, and we'll check that when you get back to